Hi everyone, I'm Pinaki from SketchX Lab, CVSSP, University of Surrey. Today I shall be presenting our latest work, FS-COCO, towards understanding of freehand sketches of common objects in context. This work was done in collaboration with Aneeshan, Ayan, Kumar, Bhunia, Xiang, Yulia, Gryaditskaya, Yi-Zhe. What is fine-grained sketch-based image retrieval? Suppose you want to search for a particular shoe that you remember. You can of course type shoe in a search engine and search from millions of shoes, or you can simply draw a shoe that you were looking for and an AI agent gets you exactly what you're looking for. We don't want to sell sketch-based image retrieval just as utility in your search engine, but a new modality for human expression that comes to us very naturally. You may not be able to speak my language, but we can draw and communicate with each other. Well, this is a good idea, but how much can we communicate by just drawing a shoe or a single object? For this, we need more. We need to describe a scene from our imagination, say a house next to mountains with rivers flowing by and birds flying. Well, let's assume that we don't speak the same language. Can you still understand these scene sketches? If you can, in 2022, shouldn't an AI agent also be able to understand the same scene sketches? In this paper, we try to answer this question: how good are AI agents in understanding our drawings? But AI agents are still data hungry, so let's begin by collecting scene level sketch drawings by humans like you and me. And we did collect data, 10,000 of them. But wait, we don't just stop there. We also ask our annotators to write a textual description of their drawings. This will help our AI agents understand their drawings and potentially avoid ambiguities when interpreting a drawing. But these captions are not only useful to AI agents, it also helps us get some interesting insights. Here we show a word cloud showing frequency of words in image captions, which are textual descriptions of images, sketch captions, which are textual descriptions of sketches. Note, some words like white or green are quite popular in image captions, but they are absolutely missing in sketch captions. This indicates the first observation: sketches do not have color information. So is sketch less informative than images? Absolutely not. Let's look at the rightmost statistics. We plot the percentage of words in a sentence like nouns, verbs, adjective. Note, sketch captions have more nouns, verbs than image captions. This tells that our sketch captions focus more on describing objects or nouns like house or duck and its actions like verbs like walking or eating. Sketch captions do focus less on adjective representing attributes of objects like a brown horse. More analysis on sketch captions is presented in our paper. Okay, so we know that what we humans describe when we are drawing, but do we all draw alike? Or in other words, do we somehow implicitly share a common drawing strategy? Our FS-COCO captures stroke temporal order information. Let's see what this temporal order information can tell us. Plotting the average length of each stroke as we keep drawing becomes smaller with time. In the beginning of drawing, we draw longer strokes, but towards the end, we draw shorter strokes. In other words, we follow a course to fine sketching strategy. That is pretty cool, but what are these longer strokes that we describe early on? Let's mask these longer strokes drawn early on, represented by the red line in the right plot. We see performance of our AI agent drops drastically as compared to masking shorter strokes drawn later. This indicates those early strokes are more semantically rich than the shorter strokes drawn later. Alright, now let's see what downstream applications a new dataset allows. First and probably the most popular is fine-grained sketch-based image retrieval. We benchmark some popular methods on how good they can understand freehand sketches. As of now, VG-based models have the highest or the best performance, but we hope more generalizable models like Clip can do better tasks in future, and we did try with them, but maybe future work can do better. Our prehistoric grandfathers made drawings in caves that we humans describe today. Can AI agents of today describe our drawings? And yes, apparently they can, and they do a pretty good job, but maybe future AIs can do a better job. Finally, to handle the complexity of scene sketches, we developed this two-layer hierarchical decoder, and the need for developing this hierarchical decoder is that object level strokes have only 100 stroke points, whereas scene has 3,000 stroke points, and we need some specific designs to handle this complexity. So now that you know a little bit about FS-COCO, what will you do next? Head over to our project space page or simply scan the QR code for more. Thank you for your time.